This is the solution to x410. Okay, so, all right. So the order in which they are square roots inverses is when the square root occurs first. So this is when radical occurs first. And squaring last. So, you know, to make sort of the assembly line diagram, that means that you have an x, and you give it to the square root machine. Out comes the square root of x. Then you give it to the squaring machine, and out comes just x. We don't need absolute value here because we couldn't have made it that far. We couldn't have done this first part unless x is greater than or equal to 0. So we couldn't have even gotten here if x wasn't greater than or equal to 0, so no absolute value is necessary. Which is to say that, you know, writing it instead of in this sort of very expanded looking way, if you do the square root first and the squaring last, then those things really do cancel each other. So they're not inverses when you do them in the other order. So that is to say, when squaring is first and square root is last. Sort of, again, as an assembly line kind of thing, you take an x and give it to the squaring machine, and out comes x squared. Then you provide that as input to the square root, and in fact out comes absolute value of x. Now the reason why that occurs is because for this is that here x can be anything, can be any real, negative, 0, or positive. It doesn't matter. But by the time you get here, x squared is greater than or equal to 0 because any negative would would get squared away by the squaring. So that's a legitimate input for the square root. But the outputs of the square root can only be greater than or equal to 0, which means that this machine has the effect of computing the absolute value of x. But to be inverses, both sides must be x. But this side is x and that side is absolute value of x. And summarizing that is to say that if you do the squaring first, followed that by the square root, then it is absolute value of x. Not just x. So in that order, they are not inverses.